find x then?
That is how we find it. Oh, so we have this, and we know that this is like equal to that, right?
Very good. So write it there, in that space,
On the
on
right.
the side, on the right. Right. Big stuff so everyone can see. Right, so he's saying 30 must have been equal to your x times what? The square root of 2. Very good. Yeah. So take it from there now. So how do you find x from there?
Do we square 30 as well?
What do you guys think? Should we square 30? What should we do, Natali? Divide what? He's saying to get x to be on its own, right, divide what?
Oh, divide by 2.
Not by 2, by...
Square root.
Uh-huh. Use a bar, use a bar. Uh-huh. Alright, so then x is equal to, next step.
X is equal to.
Just maintain your equation. On the left side you have x left, sorry, on the right side you have x left, on the left side what do you have left?
On the left side, what I have left? 30 over.
Right there.
Right over here?
No, on the left side, maintain the sides of the equation. So you're getting confused because you're switching the sides of the equation. Leave the x on the right side, right? And then leave whatever you have on the left side the way it is, yeah, like that. Is equal to x. Very good, right? So we have our length now. However, we have a problem. What's the problem? Yeah.
The square root is in the
The square root is in the denominator, so we must take care of that. How? Let's have someone else tag in. How do we take care of the square root there? She's saying multiply by the square root of 2. Let's have someone help out. Red, since you're closest, can you help out?
Right?
Thank you, sure. Yeah.
Right?
So we're going to multiply both sides by the square root of 2 over 2. Very good. Okay, next step. That's it. Right. So we're saying the side of the square is 15 root 2. Right. Everyone get that?
I'll just share the question.
And then the next step is then, how do we find the area then? Because we're not done. So let me help out here so we can move a little bit faster. So this is 15 root 2, and this is now 15. Right. So now, how do we find the area? Jun, how do you find the area now?
15 square root of 2 times
Length times width, right? So 15 root 2 times 15 root 2. But how do we multiply something like that? Multiply something like that. Just go. Yeah, one on the laptop there. Okay, so why? How do you do it, basically? How do you get to 225, or why do you get to 25? If you're trying to explain this to someone in middle school, how do you show them how to multiply? Say you did 225 5 times 2. Can someone explain why she's doing that? Yeah. Why 15 and 15? Why are you multiplying 15 with 15? Louder? The same what? They are like terms. 15 goes with 15 because they are both what? So we are. They're both rational. They're both rational. Rational goes with rational. So 15 times 15, right, goes together. And then the root 2 and the root 2 go together. Why? Because they're both irrational. Very good. The things that have square roots go together, and the things that don't have square roots go together. Ian and Liam, can you move up? Liam, come and sit over here. Ian, come and sit over here. So many of us get root 4 over there, but you can flip a square root and simplify. Root 4 simplifies to what? To 2. Right? So final answer then is 15. Alright, on the other side, same thing. Right? To find the radius here, how do I know that this is a 45, 45, 90 triangle? How do I know that this is 45, 45? Liam, how do we know that this is 45, 45, 90?
Because the legs are congruent.
Yeah, the radius of a circle is always the same. So if this is r, this also has to be r, which means the legs are congruent, so the angles also have to be congruent. So therefore, to find r, what are we going to do to find the radius there? We know it's a 45, 45, Ariana. As Ariana. Because we have the longest side. If you want to get smaller, just say you're going to take 7 root 2 and divide it by root 2. What do we get?
7.
It's just 7. If you have a triangle, right triangle, that's 7, that's how you end up with 7. And then now finding the area, we just do what? Pi times 7 squared, giving us 49. If they don't ask you to round off, you leave your answer as the exact value in terms of pi. If they ask you to round to the nearest something, that is when you take out your calculator and you multiply 49 times pi. Is that clear? Number 3 is from an SAT. It's one of the most common SAT questions. Finding the perimeter of an isosceles right triangle. So who hasn't spoken yet? Guys over here. So it's an isosceles right triangle. We know that the legs are congruent and the angles are going to be. What are the angles going to be? It's going to be a 45, 45 triangle. So you see, they won't tell you, most of the time they won't tell you that it's 45, 45. They expect you to recognize it. And we're told the hypotenuse is 10. Where do I put the 10? So this is the hypotenuse. The right side, how do I track it?
Opposite the right angle?
Yeah, opposite the right angle like that. That's where I put my 10. So we ask for the perimeter. How do we find perimeter? We add the sides. Very good. That means we need to know what this x is and what that x is.
I see fix these.
So how do we find x
Same
then?
as this.
Ian, how are we going to find x here?
It would be x over root 2.
Huh? No. Saying
Oh, x times root 2.
have taken x multiplied by root 2 to get 10. So you're dividing by root 2. So again, either way, some of you can start here, some of you start or go directly here by just taking 10 and dividing it by root 2. However, we must do what?
Why are you asking?
We must rationalize x so that we end up with x as 10 root 2 divided by 2, which gives you what? 5 root 2. That means that this side here is 5 root 2, and this side here is also what? 5 root 2. Now we can do our perimeter. What do we say perimeter is named? Add up both sides, right? Sean, you hear what they said?
No, it's fine.
So perimeter, we're doing what? Division? We're doing addition. We're adding up all the sides. So 5 root 2 plus 5 root 2 plus 10 gives us what? But what we said again, things that are irrational go together, and things that are rational go together. Things that have square roots together. So these two have square roots, so they can be what? They can be added. We're adding, not multiplying. So what do you do when you do 5 root 2 plus 5 root 2? Like having 5 apples plus 5 apples, or 5x plus 5x, you would end up with what? 10x, very good. So 5 root 2 plus 5 root 2 gives you
10 root 2.
10 root 2 plus what? Plus 10. Do I get 20 root 2? Is that equals 20 root 2? Why not? They're not like terms. I cannot add something that has a square root with something that doesn't. And therefore my answer just stops there. 10 root 2 plus 10 is my answer. Questions on this? So I wanted us to think about how to do number 2, the discussion question. Us to discuss and create a formula for the area of a square whose diagonal is x. So if the diagonal is x here, how do we find this side here? How do we find the side there? Divide by root 2. So again, having to rationalize, we end up with x root 2 divided by what? By 2. So if the diagonal is x, the side will always be x root 2 divided by what? By 2. Then now to find the area, we know area of a square, you take the side and you do what? And you square it. So the area, but that parenthesis means that that power goes on what? Everything. So x squared, root 2 squared is 2, and then 2 squared is what? When we simplify, we end up with x squared divided by in other words, what we're saying is that if you know the side of a square as x, then the area is always just going to be x squared. But if you know the diagonal instead of a square as x, then the area is going to be the diagonal squared divided by 2. It's always going to be half of the area if you know the side. We'll stop here today. Please do your homework. practicing, practice.